Alright, welcome to Doozer shop. I'm working on some side plates for the apron on the Colchester 17-inch lathe there. I started making one side plate, and this is the second one. I thought I'd plug in the camera and show you what I got. I'm working over at the Clausing 8520 milling machine. I already got two holes popped in here, the bolt holes, and now in the back I've got laid out in scribe lines clearance for the where the lead screw goes through the casting, or maybe it's the feed rod, I forget. So I got my edges located. I'm going to touch off with the end mill. I might zero the digital readout and subtract half the diameter so I get a true zero. So I'm going to set this exactly at 1.25 inches. I'm going to set a little bit less. I'm going to set 10 thousandths less, so I can do a cleanup pass. Alright, 1.240 instead of 1.250. So I'm going to come in. Alright, I'm not going to push the quill up. So I'm going to take my vise handle, which also fits on the knee, and I'll put it on the knee. Now I'm going to touch off and just kind of get a zero here on my knee dial. And you guys can't see, but you know what a knee dial is. Alright, I am cutting. I am now zeroed on the knee. Alright, so now I know, well, you know what, that was silly because I really don't care about my cutting depth, I guess, because I'm going to mill this corner out. But it's good to start where you know how much you're taking off. So let's crank in 50 thou. Because one turn of the knee crank back to zero is 50 thou, folks. On this mill, anyways. Alright. So I'm going to run into the corner. I'm going to stay like 10 thou or so away from 2 inches, and then I'm going to run out. And, you know, it helps to be familiar with your machine because when you're in a corner, you need to go out. You don't want to crank it the wrong way and go in. You know. Alright, here we go. Turn it on. I'm going to turn up the speed. Make sure my quill is locked, and it is. Okay, let me crank it up. It's about 1,000 RPM. That's 1,000 RPM for you metric folks. See what I did there? It's the same thing. And incidentally, Celsius and Fahrenheit are the same at like 40 below zero. Bet you didn't know that. Maybe you did. Smart people watch my channel. Ha! Alright, let's start chooching. Make sure my my lock is snugged on the y-axis. Alright, here we go. Look at my readout. It'll be 94, 5, 96, 97, 98, 990. Alright, I'm going to take off the X-lock. Alright, that looks pretty stellar. I get excited about small victories, you know. I mean, milling, this is easy stuff, but like it when a cut turns out. Now I'm not going to retrace this back the other way. I'm just going to go around the block and come in again, because that makes a difference. Cutting in two directions, it deflects the end mill different opposite direction. Alright, so 1.2, what did I say? 24. Alright, let me lock that axis again. I'm going to crank in another 100 thousandths. And rinse and repeat. You know what? Everybody likes smoke. I'm going to put a little cutting. What is this, rapid tap? Why not? Alright, here we go. Ow! Hot chips out! I'm going for 1.99. Making sure 5, 6, 7, 8, 9. Lock the Y, unlock the X. Alright. Maybe I'll edit this out so you guys don't have to watch the whole thing, but it's my day off. I'm in the shop. I'm enjoying myself. And I love making stuff. Alright, 1.2314. Lock the X. Put more lube on it. Not that we need lube for this, but it's kind of fun. This is a used end mill I found in the trash can. It's got a little chip out of the corner, but the other flute is okay. And for home use, this is great. Alright. Lock the Y, unlock the X, get out. And could I take the whole depth? Probably. Let me take 100 thou instead of 50 this time around. Unlock, back. Just to show you guys, I mean, it's just a conservative cut. So it's interesting, guys will argue, is it better to take light cuts and more passes or heavy cuts and fewer passes? And the argument is, if you're taking light cuts and more passes, you're wearing out the slideways of the machine because you're just doing twice as many moves. If you're doing heavy cuts and half as many passes or whatever, that you know, you're not moving as many times, whatever you're doing, and you're saving wear on the movements of the machine. But you know, you're increasing the load. So I don't know. That's a good thing to think about. I don't know, you could calculate it out engineering wise. Okay, 1.2, 3, 1. All right, I'm going to go 1.240. Okay, snug the lock. All right, so let's crank in 100 just because we are experimenting, just to show you guys, yeah, you can do it. And I could route the full depth if I really wanted to, I guess. And let's definitely use oil if I'm going deeper. Deeper screepers. Alright, let's let her fly. Wants to hog a little. Alright. 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9. 1.99. I kind of like that. Recutting chips is kind of bad for the finish. Not that we care. I could probably do another 100 thousandths cut. Unlock, move. I think that would break us completely through. I only think I got 100 left. That's cool. All right, 2, 3, 2.4. Lock the X. All right, so 1, 2. Let me cut it. Well. Alright, this should either be a razor thin line or I'm going to do another cleanup pass. So this may or may not fall off the piece. Let's see. Well, it looks connected. Six, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Lock, unlock, reverse. Chunky chunk. Watch out for the chunky chunk. Yeah. Sometimes they'll chunk out on you if you're at the very last bit of the cut because it wants to grab the edge of the piece and kind of snag it in with the end mill. Alright, unlock. Let me brush off the dovetail ways. I always keep a brush. This is like a stenciling brush made for painting like letters or something, but it's like a mini chip brush. I kind of like it. I mean, you can buy the 50-cent China bristle brushes. One, 2, 2, 3, 4. Alright, let me lock the axis so I don't forget. Now, how much is attaching this? Well, it is about a razor blade's thickness. It's like less than a razor blade. A razor blade's typically 20 thou. Yeah, I don't know if that was a good idea. Well, now that I've done it, why did I do that? Boy, that's kind of hot. You guys are laughing at me because I kind of wanted to. Alright. That's what I wanted to do. Break it off. Alright. Now, let's crank in another 100 thou. Turn it on. Let's go for a cleanup pass. Let's do that. Let's crank in. Instead of 1.24, I'm going to go 1.25. Four, five, six, seven, eight. Go to 2. How'd that look? Let's see. Let me stick my big head in the way. I'm kind of happy with that. Unlock the gid, move it back. Alright, let me stick my head in there again. Huh. A little rough of a finish, but I think it's alright. Alright, I'm gonna clean the chips off and actually I'm gonna get the vacuum cleaner and suck the chips off the mill and I'll bring you back. I'm gonna, I guess, deburr the holes and I got my deburring tool here. I do. So, this is I think it's just a hand deburring tool. And, you know, if you guys haven't used one, I mean, I'm sure you must have, but some guys, they're not exposed to this stuff. So you just kind of go around. Alright. You guys see the mill shake? It's on rubber mounts. Alright, do this hole. I'm kind of just doing this because it's in the vise. So you can get these where the tip comes out, this one, the tip does not come out. And it's like a throwaway, but it's very handy. I've had these for years, and you can sharpen them with the Dremel. Oh, and you can also do the edge. Straight piece. Like that. I mean, it's pretty handy. Alright, I'm gonna get the vacuum out, and we will proceed. Alright, I measured twice, got a cut twice. I gotta take more off, gotta take another 1/2 inch off. I don't know, maybe I got something reversed in my head. It happens. I'm gonna run this thing, I'm just gonna, instead of pecking down, I'm just gonna side mill it and get down to my number. Alright, look at that. It's kind of nice. I'm going to do another cleanup pass here. I'm going to climb it a little. You should have given it a snug when you climb. Don't climb into a corner. I'm not going to touch. Alright, so on our 1 1/4 dimension, it was 1 3/4. My brain is a little dyslexic. It kind of happens sometimes. Yeah. Let me pop it out and I'll refit it, and I'll suck up the chips with the vacuum. You guys don't want to hear that. But this is real. You know, we don't edit this stuff out. This is actual, you know. If you got a brain fart, you got to smell it. And, well, I'm not good at analogies. Anyhow, we'll bring you back. Alright guys, brought you back. I got the mill all cleaned off and I got my piece deburred. So, filming's sometimes a challenge. So, Hello, Miss June. I set the camera on top of the belt of the Atlas drill press. That was my camera mount for the previous filming. So that's kind of fun. I don't have a tripod. So let me walk you over to the lathe. Don't trip on the vacuum cleaner hose. And kind of show you where that piece goes. All right, so there's that piece, and maybe it's too dark. Hold on. This is high-tech photography, folks. All right. Let me kind of shift my thumb around the camera so I can get it in. All right, so that's what I was doing. I was milling out for the casting of the feed rod. And you can see how nicely it tucks in there. My bolts are spaced 2 inches apart, and that's a 3-inch tab sticking up. And the reason I got it, and that plate is 5 inches wide. So I got that one fitted to this side for the cross piece. And I'll explain that more in a second. So let me kind of show you the other piece. So that's the one I just finished. I don't think I filmed this one. But let me kind of go over this side. Maybe I did. And let me get the camera. All right. So that's the piece. And I cut that hole, the radius on the right side there with the rotor broach, 1 3/4 inch rotor broach. If you guys haven't discovered rotor broaches, they are pretty awesome. So now, the reason I used a rotor broach is the side of the apron is flat, and you can see where I milled to make it extra flat. But anyways, it's flat right up to the bushing. And you saw the other side, it had a protrusion from the casting to carry the bushing. The casting supports the bushing with a protrusion of material on the inside. So I think this looks pretty slick. It's got an 1/8 inch of space gap all around the bushing. So that's cool. So why do I have these wings on the side? Well, I got this piece of cold rolled. This is 1 inch by 1/2 inch. And that's going to span these two plates. And I'll show you what I got going on here. Let me kind of reorient my hand on the camera. All right, so there's the rocker box, and there's that piece of bar stock that I got milled up and ground up. So those hex bolts on the sides, on either side, might be replaced with flathead cap screws, I'm not sure. But that cap screw in the middle, that Allen head cap screw is the dog, the engagement dog, the engagement tab, the engagement tang. Many people call the same thing different names. But just to be clear, so that's in the engaged position. It's going to swing down and away. So that's, okay, so you see that plate on that side. And then let me turn the camera. And you can see the plate on that side. And yeah, I'm trying to get the best lighting here. So the bar is going to go between these plates. And it's going to notch in. Well, first of all, I thought about having notches in the plate for that cap screw, but then you're at a fixed distance. So what I'm going to do is make a not notches in the plate, notches in that piece of 1 by half inch by 1 steel bar. I could put notches in the bar, but I think I need to make 2 traveling adjustable little notches, almost like stops on a milling machine, to limit the table travel. That's what I'm going to do. So just to bring it back with the camera, so this bar is going to mount kind of up in the back here. And I know I shut my light off. I don't know why I did that. This is definitely amateur hour. Alright, now maybe you can kind of see. Yeah, you can see how it's going to notch in. Like I said, I might make some holders up, and we'll see how it goes. Yeah, I'll bring you back when I get the next step figured out.